Hello friends, today's question. The following bodies are made to roll up without slipping the same inclined plane from a horizontal plane. First, a ring of radius r, second, a solid cylinder of radius r by 2, and third, a solid sphere of radius r by 4. If in each case the speed of the center of mass at the bottom of the inclined plane is same, the ratio of maximum height they climb is. So we have three bodies: ring, solid cylinder and radius, and they are going up the inclined plane. So we have to find out the ratio of their maximum height they climb. So let us suppose this is the inclined plane and the initial position is somewhat here. V is the velocity of their center of mass and omega is the angular velocity. This is initial position and this is the final position, and let the height is given as h and r is the radius. So this is our initial position and this is the final position. So we are going to use the conservation of the energy between the initial position and the final position. Okay. So let us first of all find out what will be the initial energy at position. Let us suppose this is given as A and this is given as B. So you can say at initial position A, the kinetic energy of the object, okay, as let me write it here. So we can say the kinetic energy of the object, it will be consisting of two parts: kinetic energy because of the translation motion and plus kinetic energy because of the rotation. And let us suppose this is given as K. So I can write that value of K is equal to half mv square plus half I omega square, where I is the moment of inertia and for different objects this value will be different. Okay. And we also know that value of the angular velocity is equal to linear center of mass velocity divided by its radius. Therefore we can write that the kinetic energy K will be equal to half mv square plus half I, this will be v square upon r square. Now let us find out what will be the value of I, moment of inertia. So for a ring, moment of inertia, let us suppose, is given as I ring and its value will be equal to mass and radius square. And next is our solid cylinder. So we can say for cylinder, moment of inertia I, cylinder will be equal to 1 by 2 mr square. Now radius of cylinder is given as r by 2, so we are going to substitute it here. So this will be 1 by 2 m r by 2 whole square, and this comes as 1 by 8 mr square. And last is a solid sphere. So we can say for sphere, a sphere, its moment of inertia is given as 2 by 5 mr square, and the radius in this case is r by 4. So we get half, sorry, not half, but 2 by 5 m r by 4 whole square, and this will be coming as 1 upon 40 mr square. Therefore, now we found the moment of inertia. So respectively, now we can find out using this equation the respective their kinetic energy. We can say using equation 1, kinetic energy for the ring will be equal to half mv square plus half inertia of the ring, that is mr square, and multiply by v square upon r square. So r square cancels out. This will be coming as half mv square plus half mv square. Okay, so this will be equal to mv square. Similarly, for the cylinder, we have half mv square plus 1 by 2, and moment of inertia is 1 by 8 mr square, and it will multiply by v square upon r square. Once again, r square and r square cancels out, and we are going to get this equal to one second please. This is radius. Yeah. And now the radius is r by 2. So this will be multiplied by 4. Okay, this will be r square by 4 multiply, and this will be coming equal to as this 4 goes by 2, and this will be equal to, let me write it here, half plus 1 by 4 mv square, and taking 4 as LCM, this will be 2 plus 1 mv square, and we get K for the cylinder is equal to 3 by 4 mv square. Now let us find out similarly for our sphere also. So you can say kinetic energy for sphere will be equal to half mv square plus half the moment inertia of the sphere is 1 upon 40 mr square, and its radius is given as r by 4. So this will be v square upon r square multiplied by 16. So if we solve it, we are going to get K sphere. This will be our 8, and this will be a 5. So we get 1 by 2 plus 1 by 5 mv square. So we are going to get this as 10 will be our LCM. This is 5 plus 2 and mv square. So kinetic energy of the sphere is equal to 7 upon 10 mv square. So we found out the kinetic energy for all the three objects. Now we are going to find the potential energy, because at final position, at initial position, the value of the potential energy will be 0, only the kinetic energy will be present, and at the final position only the potential energy will be present, its kinetic energy will be equal to 0. Therefore now we are going to find out that potential energy. Okay, so we can say potential energy at point B. So we get this as will be equal to mg h max. Okay, so in this case this is our height h. Okay, but we are finding the moment of inertia with respect to this center of the objects. So therefore there will be additional height, and that will be r, and this will be our h max. Okay, so we can say here h max will be equal to r plus h, where h is the height of this inclined plane and r is the radius, so h max. Now we are going to use conservation of energy. So we can say by conservation of energy, initial energy is equal to final energy. So initially energy at point A will be equal to final energy at point B. So initial energy will be potential energy at A plus kinetic energy at A will be equal to potential energy at B plus kinetic energy at B. So potential energy is our 0 and B at kinetic energy is 0. So we get kinetic energy at A will be equal to potential energy at B, and kinetic energy in A is given as K and potential is given as mgh max. So from here we can say h max will be equal to K upon mg. Now we are going to use the values which we found out for various objects. So first is for our ring. So for ring we have h max ring is equal to energy for ring is our mv square divided by mg. M and m cancels out, so this comes as v square by g. Similarly we can write for cylinder, you can say our h max for cylinder, and the kinetic energy for the cylinder is 3/4 mv square divided by mg, and once again mass and mass cancels out, so this comes as 3/4 v square by g. And next we can find out for the sphere also. You can say for sphere h max for sphere, kinetic energy for sphere is 7 by 10 and mv square divided by mg. Here m and m cancels out, so this comes as 7 by 10 v square by g, and we are supposed to find out their ratio. Therefore we can write that the ratio of h max for the ring to h max to cylinder and is to h max to sphere. So this will be coming equal to as v square by g is to 3 by 4, v square by g is to 7 by 10 v square by g. So we can write this as 1 is to 3 by 4 is to 7 by 10, and this will be equal to 40 is to 3 into 40 divided by 4 is to, this will be 7 into 40 divided by 10. So this comes by 10 and this goes by 4. So we get this will be equal to as next page. So this will be equal to 40 is to 30 is to 28, and this taking the common, so this will be coming as 20, 15 and 14. 20, 15 and 14. So this will be the ratio of maximum height. This will be a ratio of maximum height. So in this case, please remember that I calculated rather the height with respect to the center of the circle, object. Okay, and if we want to find out actual h, then we can use the theorem of parallel axis for each object rather, and find out the moment of inertia about the point of contact. Okay, let me write it here. This calculation is for different objects by considering the moment of inertia about the center of the objects. No doubt the answer will be coming same, because in every object this r will be added. For cylinder it will be h plus r, for sphere also it will be h plus r, as well as for the you can say ring it will be h plus r. So r will be a common factor in all the things, all the objects rather. So that's why it will be coming as answer will be same. And therefore we can say the maximum height h max is equal to h plus r. where h is height of inclined plane and r is radius of objects. Now in case we want to find out only for h, or we can say with respect to the height of inclined plane, for calculating maximum height with respect to height of inclined plane, we have to use theorem of parallel axis and calculate moment of inertia about the point of contact. This will give us h. This will give h. So basically means that this is inclined plane and this is our object. So we calculated the moment of inertia about this, and suppose P is the point of contact. So we are going to use theorem of parallel axis to find out the moment of inertia about the point of contact. Okay, so because of that, in this case, this will be the point of contact, and now we are going to get the h. So in this case, this h will be h max. As we are supposed to only find out the ratio, addition of a constant value doesn't matter. Okay, so this will be giving us theorem of parallel axis. We are going to find out the moment of inertia about the point of contact, that is P. This will be giving us h, which will be our h max. Okay, so we can do it either way. Thank you. In this case, the option number C is the correct option. Okay. So you can say that option C is correct. So this completes the finally now question. Okay, I missed this point. Thank you.